Despite an explosive summer at Yellowstone National Park, marked by a thermal feature eruption that destroyed a boardwalk and sent visitors fleeing from an eruption of black water, mud and rocks, a recent study provides reassurance. Researchers have confirmed that the park's famous supervolcano will unlikely erupt anytime soon. According to an analysis published last week in the journal Nature, while a significant amount of magma is beneath the Yellowstone Caldera, it is stored in small, separate pockets rather than a flowing reservoir, reducing the likelihood of a major eruption. For Michael Poland, the scientist in charge at Yellowstone Volcano Observatory, this finding was far from surprising. "We've known from seismic imaging that the magmatic system was mostly solid," he said. "The Yellowstone system is one that's been stagnant for a long time." The volcano's largest eruption, which earned it the title of a supervolcano, occurred 2.1 million years ago. According to the United States Geological Survey, it released so much magma from its underground reservoir that the ground above collapsed into the magma chamber, forming a massive depression larger than the state of Rhode Island. This enormous crater, known as a caldera, spans up to 80 kilometers long, 65 kilometers wide and hundreds of meters deep, extending from outside the park into its central areas, according to the USGS. Since its formation, the caldera has seen relatively limited volcanic activity. The most recent rhyolitic lava flows occurred around 70,000 years ago, and since the last major caldera-forming eruption 631,000 years ago, approximately 80 mostly non-explosive eruptions have taken place, according to the USGS. Poland said for the volcano to erupt again, Yellowstone's magmatic system would need significant rejuvenation, likely driven by heat energy from a magmatic intrusion into the current stagnant magma bodies. Now, the good news is that kind of event would be accompanied by all sorts of changes. We would see seismicity, we would see really intense ground deformation and changes in thermal emission and gas emissions, he said. While the exact timeline for such a rejuvenation remains uncertain, Poland estimated it would likely take decades, at a minimum, and, more realistically, centuries to millennia, to trigger an eruption. It may be that we see really abundant activity for quite a long time before there's an eruption, he said. Despite the study confirming that Yellowstone's magma is more solid than liquid, Poland emphasized the need to focus on more immediate risks and hazards in the park. "Those are the hazards that are going to occur again, likely within our lifetime," Poland said.